Bismillahirrahmanirrahim. My name is Nur Atika binti Hasman. Today, myself, with my friend Nur Hafiza, would like to present our Lab 1 for Medical Instrumentation. The topic is Investigate Biomedical Instrumentation Transducer. So, I would like to pass to my friend.
Okay, for the 3.1, this is an ideal strain gauge transducer with a Wheatstone bridge circuit. The component used to run the simulation is multi-sim version 11. We are using a resistor with the 120 ohm value. To build the circuit, we are using multi-sim 11.0. And the component used is 5 volt DC voltage and 120 ohm resistor. For the 3.2 task, it is the circuit that has built and connected with multimeter and oscilloscope to find the voltage and current. When the simulation is run, the output produced from the multimeter is 0 and also oscilloscope because the Wheatstone bridge circuit is at stable state. Next, I will pass the presentation to Atika.
So for 3.3, it divided into three models, which is model 1, model 2, and model 3. The first one is model 1, which is we change the resistor, we change only one resistor into potentiometer resistor, which is we use from 20 ohm until 200 ohm. Okay. The first one is 20 ohm. We change the resistor into 20 ohm. So and then we find the current and the voltage from the voltmeter. So this is the value. Same goes to the next one, which is 40 ohm for the R4 resistor. And next is 60 ohm. After that, we use 80 ohm, 100 ohm, 120 ohm. Basically, we just change the value of potentiometer resistor. So the way to find the current is the same. Just put the multimeter at point A and B. So next is 140 ohm, 160 ohm, 180 ohm, and 200 ohm. For model 2, we change the two resistor at R6 and R8 into potentiometer resistor. Also, we started from 20 ohm until 200 ohm. So this is the circuit. And then also we calculate the current using multimeter, same as previous model, which is put the multimeter at point A and point B. So this is the 20 ohm value of potentiometer resistor. The second one is 40 ohm. Next 60 ohm. After that we use 80 ohm. We get 10.417 milliampere, sorry. Next is 100 ohm, 120 ohm, 140 ohm, 160 ohm, 180 ohm, and 200 ohm. We get negative 8.333 milliampere. And the last one is model 3. We change all the resistor into potentiometer resistor, which is R9, R10, R11, and R12. Also, we started from 20 ohm until 200 ohm. The first one we got 0 because it is a stable circuit which produce zero current because it was balanced. The second one also 0 because all the resistor is the same value. Same goes to other value because we use the resistor all the same. This one 100 for resistor with 100 ohm. This is 120 ohm, also the same. But when we use 140 ohm, it becomes smaller value of current, which is 444.0 444.089 nano ampere. The next one is 160 ohm. This is circuit for 180 ohm, and the last one is 200 ohm. So for model for 3.3 also it asks us to find the voltage. The previous one I showed to you is the current. So the voltage, we just change the multimeter into the volt, and then we get the answer. This is the model one for 20 ohm, 40 ohm, 60 ohm, 80 ohm, 100 ohm, 120 ohm, 140 ohm, 160 ohm, 180 ohm, and 200 ohm. For model 2, also we use the same circuit for previous one, just change the multimeter into volt, and then we get the voltage output, which is the first one 20 ohm, 3.571 volt, and then 2.5 volt, 1.667 volt, 1 volt, 454.545 millivolt for 100 ohm. For 120 ohm, we get 0 volt. And then this is 140 ohm, 160 ohm, 180 ohm, and 200 ohm. And the last one, also model 3, same as the previous that I explained before. It is negative 552.783 pico volt for 20 ohm. So this is for 40 ohm, 60 ohm, 80 ohm, 100 ohm, 120 ohm, 140 ohm, 160 ohm, 180 ohm, and 200 ohm. Okay. So I would like to simplify our results into table. This is the model 1 result for current and voltage. And as we get the value of current and voltage, we can find the power, which is P equal to IV. So we calculate the power, and then here is our result. You may see from the table. This is for 20 ohm, 40 ohm, we get 17.361 milliwatt, and then and so on until 200 ohm. Also for model 2, we also find the power by using the formula of P equal to IV. We just substitute the value of current and voltage, and then we get the value of power. This is the power for R6 and R8 20 ohm until 200 ohm. As for the model 3, also the same, because we previously we just find our current and voltage, so just substitute and we get the value of power until 200 ohm. Okay, next. For 3.4, it asks us to propose the optimal value for each model. So we just find that the parameter of strain gauge basically is how we observe the sensitivity of the strain. Basically, the sensitivity of the strain can be measured by choosing the highest voltage output between the 2 points from the Wheatstone bridge that we calculate before. So the combination of ratio between the all resistor will produce an output voltage. It shows that the highest the output voltage will produce the which will have the highest sensitivity. So it is suitable optimum value can be determined from choosing the value of resistor that produce the highest amount of voltage output. For model 1, we can see that the highest voltage output is when the resistor is 20 ohm, which is the value of output voltage is 1.786 volt. For model 2, we can see that also when the potentiometer of resistor is 20 ohm, it produces the highest output voltage, which is 3.571 volt compared to others. For model 3, also we choose the highest voltage output, which is when we use the resistor is 200 ohm. It produces the highest voltage, which is 2.185 nanovolt. Okay.
Okay. For the task 3.5, we are adding a basic differential amplifier to each model because it is used to amplify the input signal conditioning with a closed loop of negative feedback. Okay, this is the circuit when op-amp is added. The value will be changed at the negative feedback resistor, which is RF. For the model 1, at the R4, we are choosing 20 ohm resistor because as proposed at from 3.4, the optimum value, which is it has a high value of voltage. Okay, for the feedback resistor, the value will be changing 10% ranging, which is from 10 kilo ohm until 100 kilo ohm. Next, for model 2, the same technique is applied, which is the RF resistor is changing from 10 kilo ohm to 200 kilo ohm. The potentiometer is changed at R6 and R8, which is 20 ohm, and it gives the value which is negative 2.981 volt. The negative value represent the negative feedback. For model 3, the potentiometer value used is 200 ohm and the feedback resistor is still changing from 10 kilo ohm to 200 kilo ohm. The given value when the feedback resistor 10 kilo ohm is 2.044 volt. In my opinion, it should be zero value, but maybe this circuit is highly sensitive, so it still produce the voltage output. After gain the voltage and current, we conclude it in a table. As you can see, to find a power for each model, the power is calculated using the P equal to IV formula. The value of power is starting from for 10 kilo ohm feedback resistor is 1.438 until, can you scroll down, until 14.5008. It is repeated for model 2 and model 3, whereas the value is changing based on the based on its voltage and current value.
So this is how we calculate all the value from the question itself, and we get all the value using the circuit given and then using the multisim. So that's all from us. Thank you.
Thank
Have a
you.
nice day. Bye.